developments have helped government agencies innovate faster and more effectively than the evolution of the cloud. I'm Wyatt Cash with Scoop News Group, and here to talk about cloud's impact on the public sector and how that's fostered innovation is Zachary Goldstein, CIO and Director of High Performance Computing and Communications at the National Oceanic and Atmospheric Administration at the Department of Commerce. Zachary, thank you for joining us.
Thanks for having me.
So let me set the stage a little. How has the cloud enabled NOAA to make significant improvements in the services that it delivers to the public?
Mm-hmm. Well, one of the most important things about moving to the cloud is freeing up people, because we have shortages of IT technical talent, to work directly on our mission applications. We have a lot of unique things that we do in NOAA that you can't go buy as a software as a service or buy, and it's not infrastructure as a service either. Things like the models that we create that give you a weather forecast or your climate projection. But there are things that the cloud directly provides us, and we've got some good examples to share with you today. First of all, not too long ago, we moved the major web farms that we have that serve up everything from information about sustainable fishing to the hurricane track from the National Hurricane Center, or the detailed output of a model, or weather in your location. Those are all served up in a number of modes, but the most commonly understood one is over the internet. And to enable us to handle the onslaught of workload that occurs when you're tracking a hurricane, and if it's going up the East Coast, and you've got all these populated areas and people interested in where's the hurricane going, what we did was we placed in front of both our weather.gov set of websites and the NOAA.gov set of websites, which includes the National Hurricane Center, among others. We've put them behind cloud-based content delivery networks. And since having done that, putting them behind CDNs, no matter what happens with the workload because of the interest, I'm told that the two most popular websites in the government in the past, I'm not sure if that's still true, have been NOAA.gov and weather.gov, unless it's tax season, in which case it's IRS.gov. That may have changed, but they're very popular. Getting a billion hits in 24 hours is typical if it's a hurricane track that people are interested in. And the CDNs, the cloud-based CDNs that they're behind, have contributed greatly to our ability to weather that onslaught of interest and not give people a bad experience in terms of a slow response time to a query. We put them in because availability is so crucial to our ability to get information out. Lives and livelihoods are at stake if our timely information makes it out or not. The content delivery networks are backed up by on-prem systems. We have a hybrid to generate the content and be able to serve up the content should the content delivery networks fail. So we've got the first line of content delivery network, but right behind it, we have very robust web farms that are managed on-prem. So that's one thing. Another thing I'd like to highlight as something that's been a major achievement is the use of cloud through the NOAA Big Data program. And this is a unique arrangement where at a fairly low cost to the taxpayer, we have partnerships with the three big cloud providers, Google, Amazon, and Microsoft. And under these partnerships, they have a business arrangement. They're making money. And as a consequence, the taxpayers don't have to pay any substantial additional amount to get the data they've already paid for and the processing they've already paid for into the cloud so they can access it in the cloud. And some amazing things have happened through the big data partnership in terms of building on NOAA data in innovative ways. The program allows near real-time access to satellite information, for example. And one of the things that has been enabled by that is something called Mayday.ai. Check it out. It's a service that was put together by third parties that, by using our satellite data and other data, But one of the things that's really enabled by our satellite data is the ability to effectively predict when lightning is going to cause a forest fire. The imagery from 22,000 miles up, the secondary markets use of Mayday AI in Mayday.ai allows that imagery to be interpreted as, here's the lightning strike, and here's where a wildfire might start based on our machine learning algorithms. So that's a pretty cool application, only enabled by the fact that not only do we have this data in the cloud, but we have it in this special arrangement that we have that is very efficient and provides the ability for people to get data out of the cloud at no cost to taxpayer. The other thing we're doing is we've put our models in the cloud for easy access. And I guess the last comment I want to make about sort of an interesting connection between cloud things and benefits directly to people is it takes massive amounts of telecommunications to move the terabytes of data that we get from our radars and from our satellites. We're probably the original big data agency. To move that data around and get it to the cloud requires massive networks. And we have this network called NOAA. And when we make investments in capacity to move our data around, we end up being a big buyer. And what that does is that lowers the cost of network and internet access at the places where we buy our pipes. So in West Virginia and Alaska, access to the internet from rural communities becomes less expensive to whoever's providing it because we're a big buyer in those locations. So those are a variety of effects.
Well, and some very impressive examples, both on the scale of visitors, the amount of data that you're using, and the residual effects of operating big networks. So thank you for sharing that. Let me dial it back a little bit. What were the primary technology challenges that your agency was facing in delivering services like that, before you were able to fully take advantage of the cloud? And, how did the cloud ultimately help you overcome them?
Right. Well, the cloud is helping us to overcome them. It's not done yet. The biggest challenge we have is actually something I mentioned at the very beginning, and that's having enough technical talent to support the transformation of good ideas out of our scientists and our engineers into services that benefit the public directly. The pacing function of what we call R2O, research to operations, that gives you a better forecast, that gives you a better climate projection. The pacing function is the IT that you use to transform those ideas into models and the models into operational products. And so one of the limitations to get that talent, to get access to that talent, is to unburden them by making sure they don't have you don't have to worry about that box under your desk. You don't have to worry about that financial application. We can get it through software as a service. You don't have to worry about that email application. We can do that here. In fact, it's a decade now that NOAA became the second agency in the federal government to move email and collaboration services to the cloud. Every time we do that, every move we make to the cloud frees up additional talent to drive the mission. And so it's a continual process. That's probably the biggest thing that we had that was in the way. It also saves us money, not just talent, because generally you get good economies of scale. And the other things that it does, and this is not trivial at all. I already gave you the example of the web, where if you get enough hits, it can slow down your service. Well, our on-premises systems that host the modeling data that is of great interest to the weather industry, the multi-billion-dollar industry that exists on our data in the first place, they put enormous burdens on our infrastructure. And you have a upgrade cycle, you have a lot of cost and budgeting. It's very hard to keep up with it. When we move things to the cloud, just like in the web example, the same thing happens with processing. So right now we have an example where through the big data program, we're serving up model data. And that's taking pressure off of the dissemination systems that we have so that they can do a better job at what they do. So the cloud takes pressure off of on-prem systems that aren't nearly as agile in terms of their capacity. It also helps in data center consolidation, right? If instead of putting things into one big data center and just moving all this big iron from one place to another, if you move to the cloud, it's not your problem anymore, at least not as a data center. Still a lot of work to be done because security doesn't go away. A lot of things, a lot of responsibilities don't go away when you move to the cloud. But it does help with those technical challenges of managing data centers, having enough technical people, and just the burden that the success of our mission places upon our infrastructure. It's a lot easier to keep up with that demand when you're in the cloud.
Great. Well, next, maybe could you describe a couple of key outcomes that the cloud has allowed your agency to achieve, maybe compared to where you were a year or two ago, that kind of is an example of innovative ideas or services that does benefit the public?
Okay, well, the two I've already mentioned. The
Mhm.
content delivery network is direct benefit of the government, as was the big data program, right? Um, Something that I just alluded to a moment ago is the mechanism we're using right now. We're talking via cloud, but every day NOAA does its work of transforming ideas and innovations um, into operations by collaborating in the Google Cloud, uh, because we implemented a decade ago. And you mentioned 2 years, and what that struck me is that that's about when the pandemic began. And we've been able to keep up our pace of model release, innovation, unfettered by the pandemic, because people who used to do all that work together are doing it via the cloud. They're collaborating in the cloud. We've bought additional software as a service applications to facilitate that collaboration, and these cloud-based tools enable us to keep our innovative pace going, despite the fact that we're in a pandemic. Um, the Something else that I'd like to throw out that's helping us with innovation is in our high performance computing world. High performance computing in NOAA is unique. We don't work on what we put in we don't work on using something that this is a term that we use in high performance computing, embarrassingly parallel problems. Our problems are not embarrassingly parallel. You can't divide up a weather model and process it, half of it in one data center and the other half 10 miles away in another data center or around the world. Because each cell in the model has to interact with all the other cells. So it requires raw iron, a lot of power in one place, very close to each other. That doesn't mean you can't put it in the cloud. And what we've been able to do is create, and we've done a lot of this to actually stimulate the industry for the type of HPC that we used, have it be available in the cloud. We now have cloud services from the same three vendors I mentioned earlier in the BDP program. They also provide high performance computing as a cloud service, and we use that to speed innovation, because when you only have so much capacity, if you've got, individual science projects aren't, like level work. At some point I've got my ideas. Okay, it's ready to be tested in the computer. What if there's a queue? Because it just happened to occur. By having the cloud available, in addition to the massive amounts of capacity we have on-prem, and it is impressive, it's a lot. But by having the cloud, it can handle that get that scientist from having to be in the queue anymore. And now everybody can move along at the pace of innovation. So it speeds up the innovative process and that transformation of research to operations. And we did it in a way that the scientists, while they know they're in the cloud, they didn't have to change how they log in. They didn't have to change how they authenticate. None of the networking is the same. So we've brought the cloud in behind the networks that we use for high performance computing to maximize the user experience, minimize the disruption. So the cloud is just another great service for our high performance computing customers who are doing the research that's the innovation engine of NOAA.
It's a great example. Well, then lastly, Zachary, what one or two key lessons or maybe even surprises that you experienced moving to the cloud, and where do you plan to adopt additional cloud services next?
Well, one of the surprises that came from not so much moving to the cloud, but having the cloud move to us, and I'll explain that in a moment, is the management challenge of software as a service. So it's one thing to do what we did a decade ago and choose to go to software as a service for email and collaboration. It's another thing when software as a service chooses you because a vendor that you've been working with for a number of years and you get their software either online or used to be by a disk, and you'd install it and it'd be in your environment and it'd be protected. And yeah, maybe it had some bugs and it would get patched routinely. But the environment it's sitting in, you know that. You built it. You know who accesses it, who controls it. You know what its perimeter looks like. Imagine one day they decide, without consulting you, we're going to go to the cloud. You have no idea of what the security is associated with that. And so it's, this is almost a cliche in our business. Fill in the blank changes everything. Software as a service really did change everything, because now with a credit card, an individual employee can go out and all of a sudden there's an application that NOAA data is being processed against, or government data is being processed against, and you don't actually understand. It may not be FedRAMP. It's possible nobody's looked at it. So it's implement a real control challenge for all of us. It's the whole idea of having software on your desktop means it may not be anywhere near your desktop. And so, but it's not like we're not rising to the challenge. The same technologies, cloud access security brokers, CASB, as the acronym is, that we use to monitor our cloud instances, the ones we choose, that give us all the telemetry that we would get if it was on-prem. So that security posture is, and when we integrate it, it's the same. They also have discovery mode. They can go out on the internet and tell you who in your IP space is accessing what and what are they doing with it. So what we've been doing is using that discovery mode to identify the instances, bring them in to a management framework, and do the work to, while we move to the cloud intentionally, deal with the unintentional aspects of the cloud environment itself. That's probably the biggest challenge that we've discovered, a lesson learned, and I share that because I'm not sure people are attuned to how much the change in the environment is changing the security posture unwittingly. And I wanted to get that out there. The other thing that I was something you think about is to protect our means of protecting America, to protect our ability to generate a forecast, for example. We try to isolate those applications from the internet as much as possible. On the other hand, to get the word out, to protect America, we have to access the internet to get the data out. So we have this opposite focuses from a security perspective. Protect your ability to disseminate while protecting the ability to generate at the same time. Cloud complicates that a bit because when you go to the cloud, you're inherently increasing your attack surface from the internet. So that means you have to look carefully at the controls that are out there. It means that things like, you have to think very carefully about their protected environment. Anyway, so that's, those are the security lessons learned are probably the biggest ones. Additional cloud services, you asked where we plan on going. Well, we're continuing to migrate our administrative systems and our mission systems. NOAA, as part of the Department of Commerce, you gave them the right props at the beginning of this meeting, is going to the cloud in our general business systems. There's a business application, this is a program called BASS that the Commerce Department's running that we're a part of. But in addition to that, one of the things I think is really cool about where we're going is in citizen science. NOAA's always been a citizen science agency, from when people had rain gauges in their backyards and fed our networks to today with AI and machine learning. And one of our charges is to have the models that we use to protect lives and livelihoods be informed by private sector modeling and academic modeling. And then when they use our models and find improvements, we take those improvements and feed them back into ours so we can take the best minds on the planet to protect the lives on the planet. Cloud can play a critical role in that, because people don't have high performance computers to run models in their basement, but they can access HPC in the cloud. So what we're doing is we're making our models cloud ready. Through the big data program, we'll be able to put out the data that we use to initialize those models, and then begin this, do what the Congress of the United States has charged us to do. We're doing it somewhat right now because academics have high performance computers, and we're sharing. We're doing what Congress asks. But imagine how we can amp it up if we can make the data and the models available to anybody in anybody's cloud platform. I'm excited about that. And that's one of the places we're going with the cloud.
Well, it certainly sounds like not only are you experiencing the power of innovation, you're really allowing the public to share in that innovation as well. So thank you so much for sharing all those examples. And Zachary Goldstein, thank you so much also for your time today, just sharing the lessons you've learned about putting the cloud to work at NOAA.
Thank you for inviting me.